Ever pondered why a golf ball has dimples or why an airplane wing is curved? The answer lies in the fascinating field of fluid dynamics. Fluid dynamics, a subset of fluid mechanics, is the study of the behavior of liquids and gases. Now you might wonder, what does this have to do with dimpled golf balls or curved airplane wings? It all comes down to the concept of flow. Just imagine a river, peacefully flowing downstream. It doesn't move in a straight line but meanders, curves, and swirls. The water's movement depends on many factors, including the riverbed's shape, the water's speed, and even the temperature. This is a simple example of fluid dynamics in action. In the same way, the flow of air around a golf ball or an airplane wing is affected by their shapes. The dimples on a golf ball create turbulence in the layer of air next to the ball, reducing drag and allowing the ball to travel further. The curve of an airplane wing, known as its airfoil, creates a pressure difference between the top and bottom surfaces, leading to lift, which allows the plane to fly. But fluid dynamics isn't just about golf balls and airplanes. It's a fundamental part of many natural and man-made processes. The weather patterns we experience, the flow of blood in our bodies, the design of cars and buildings, the production of power, and even the spread of pollutants in the air or water, all involve principles of fluid dynamics. Moreover, fluid dynamics is governed by a set of equations known as the Navier-Stokes equations. These equations, though complex, can describe the motion of any fluid under any conditions. They take into account factors like viscosity, or the stickiness of a fluid, and pressure, or the force exerted by the fluid. The principles of fluid dynamics may sound complex, but they're really all about understanding the world around us. From the flight of a bird to the swirl of cream in your morning coffee, fluid dynamics is at work. To summarize, fluid dynamics is the study of the behavior of liquids and gases. It's crucial to many natural and man-made phenomena, from the flight of airplanes to the flow of blood in our bodies. Its principles are governed by the Navier-Stokes equations, which describe the motion of any fluid under any conditions. So next time you see a golf ball fly, an airplane soar, or even just a river flow, take a moment to appreciate the complex yet beautiful science of fluid dynamics at work.